Hey guys, welcome back to another lab. So for lab 4, we did the bar magnet lab, and this is by myself, Montelos Benavides. So here what we looked at was the field strength from a magnet in terms of its varying different distances and positions. So pretty much it's just magnet placed at different points, and we're looking at the magnetic field strength for each of those different points. The equations that we used were for the on and off axis magnetic fields found from the Biot-Savart law. We used some coding to model and analyze the situation and used the spreadsheet to create a graph as well. So we tried to find the dipole moment to find the magnetic field at different points, and we pretty much just found that it goes from south to north poles, like always, and just found that the magnetic fields vary based on location. So some of the equations that we used were the following, which was for the magnetic dipole, magnetic loop, for its vector, and then for the dipole moment as well. And these were just used within our calculations. So the lab set up a procedure. We had a magnometer, which was placed at the different observed locations, and it's what we consider to be our system. It's pretty much just an app that was installed on our phone called Firefox, and that was our magnometer. The bar magnet and the meter stick served as the surrounding environment, which is what gave the magnet gave the magnetic field, and then we measured on both axes to determine the different values, and the values collected were, the strength of the magnetic field at each of those given locations. So lab results and data, pretty much these are the calculations that we performed. To the right, you can see our spreadsheet that has all the different data that we inputted, which is just pretty much the different locations and then the values that we measured for the magnetic field at those locations. Of the statements, what we can agree with is that when the magnometer was far away from the magnet, it measures a near zero magnetic field in the x direction, which is true, and the magnometer moves closer, and then as the magnometer moves closer to the magnet, the measured x component of the magnetic field increases. Now, in terms of GlowScript code, this is everything that we had. It pretty much was just, we had to write code for the magnetic field. We had to input different distances. We had to, a lot of it was also establishing the axes and having arrows going for the different values for different magnetic fields. And so to the right, you can see all of those values that we got along with the drawing for it. And so the different values between the experimental results, which was the spreadsheet we just saw, and this computational version was just because of probably some external magnetic fields and human error. But the external magnetic fields that could have been at play were other magnets, laptops, phones, all of that cause magnetic fields that weren't accounted for. And so for what if, what does it mean? What if we didn't orient the experiment to compensate for magnetic north and instead laid out the meter stick at some random angle with respect to the magnetic field? How would that have changed the results? So the magnetic north would have messed up the data along the x-axis because that means we would have accounted for magnetic north plus the bar magnet, which would also have thrown off our y components. And then what if we stuck the two identical magnets together end to end? How would that change our measurements? And pretty much the magnetic fields would have been stronger because there would have been combined force of two magnets rather than one, which means it would have been double the value. Thank you guys.